We're going to look at shifting equilibria with common ions or reacting species. Yesterday, we looked at shifting equilibria by either deliberately adding or removing reactants or products, or we changed the temperature, or we changed the container size, which affected products or reactants in the gas phase. Today, what we're going to look at is a little more subtle. We're going to add what are called common ions. Those are ions that are already present in the equilibrium, or we're going to add something that will react with things that are in the equilibrium. So let's take a look at an example here. We've got a solution of cobalt tetrachloride in ethanol, and we can see from the equilibrium that we have pink and blue. So one of them is blue and the other one is pink. So here's the question. Which way will the reaction shift if solid sodium chloride is added to the solution? Justify your answer. So here's a hint. Sodium chloride is soluble. If we put it in water, it's going to dissociate completely to form sodium ions and chloride ions. So what that means is we have added chloride ions. So the reaction is going to shift to consume the extra chloride ions. This is just like yesterday, okay? The chloride ions react with the pink cobalt H2O6 2-. So that means that the pink color is going to fade away to produce more of the blue cobalt tetrachloride. So the reaction is going to shift in the left direction. Now, we have told the reader which way it's going to shift because we said we're going to be producing more of the blue cobalt tetrachloride. Let's take a look at the next change that we're going to do. It applies to the same system. Which direction will the system shift if solid silver nitrate is added to the solution? So here's a hint. As soon as we put silver nitrate into water, because it's got nitrate ion, it's going to decompose to form silver ion and nitrate ion. Now, neither one of those are in our equilibrium. However, notice that the silver ion will react with the chloride ion to remove, or the chloride ion by forming solid silver chloride. So this time, our chloride concentration is going to be decreasing. So the silver plus reacts with Cl minus to remove Cl minus from the system. The system shifts in the forward direction to replace lost Cl minus. Okay, when that happens, we are going to form more of the pink cobalt water complex. So more pink cobalt H2O6 2+ forms. So in this case, we should see the solution go from kind of a purplish color if we had a mix. It's right up here. Mix would be purple. to more of a pink color. Let's take a look at another color-changing equilibrium system. This is the chromate and dichromate ion equilibrium. So we have chromate ion, which is yellow, and in the presence of a small amount of acid, we also have the dichromate ion. So which direction will the equilibrium shift if HCl is added to the solution? Justify your answer. Let's again write up here that if we have a mix of these, mix would be orange. Red and yellow make orange. All right, so we've added extra H plus because we know that HCl decomposes or dissociates 100% to form H plus aqueous and Cl minus aqueous. We do not care about the chloride ion, but we do care about the H plus because we see it's right here, okay? The system will shift to consume the added H plus. Okay, when that happens, the yellow CrO42 minus reacts with the H plus. And more red dichromate ion forms. Let's take a look at instead adding sodium hydroxide. So way back we talked about neutralization reactions. So let's take a look at what's going on. If we put sodium hydroxide into water, it will dissociate completely to form Na plus OH minus. In turn, OH minus is going to react with H plus to form H2O. Okay? So, two things are going on here. We are removing H plus. Okay? So, as we remove the H plus, the system is going to shift to replace the H plus. Now, you might be looking at that and going, well, okay, we're also making more H2O. But notice that we have two H pluses and only one H2O. So as we remove the H plus, the system will shift to replace H plus in the reverse direction. So more of the yellow chromate ion forms. Okay, I'm going to rewrite this equation up here. 2CrO4 2 minus plus 2H plus is in equilibrium with Cr2O7 2 minus plus H2O. So our net effect when we added the hydroxide was that we removed H plus, and at the same time we actually increased the water. Both of these changes are going to make the reaction tend to shift in the reverse direction. So by removing H plus, the system shifts to replace the H plus in the reverse direction. We've also added water, so it's going to move to consume the water in the reverse direction. So we're going to get more yellow of the chromate ion forming. Okay, we've got one more example to go. So here we go with that. Example 3, we have iron 3+, which is a nice pale yellow color. We add SCN. This is colorless. That's why we don't have a color with it. And this is in equilibrium with iron thiocyanate. That's called a complex ion, which is a deep red color. So our first question is, which direction will the equilibrium shift if iron 3 nitrate is added? So I'm going to pause there and give you a chance to put an answer down. Okay, so I've rewritten the equation here, and I put a little arrow underneath the iron to show that we have added iron Fe3+. So the reaction will shift to consume the added Fe3+ in the forward direction. Now, notice as we do that the cyanate ion is going to go down and the iron thiocyanate is going to go up. More red of the iron thiocyanate forms, and we're going to see the solution get redder. So now let's try the next question. Which way will the equilibrium shift if potassium thiocyanate is added? So I'm going to pause and you're going to give this a try. I've rewritten the equation. So we have the iron 3+ plus the thiocyanate. In this case, we've added SCN. So let me put a little arrow underneath here. This means the reaction will shift to consume the added thiocyanate, and again, more red iron thiocyanate forms. Our last question is, which direction will the equilibrium shift if sodium hydrogen phosphate is added? And I've got a very important hint for you here. So iron 3+ plus hydrogen phosphate forms insoluble iron hydrogen phosphate. So I'm going to pause and you're going to give this a shot. The sodium hydrogen phosphate is going to remove iron 3+ from solution. So the system is going to shift to replace the lost iron 3+. This is going to consume the red iron thiocyanate and more of the yellow Fe3+ forms. So if you remove enough of the iron, what eventually ends up happening is you've removed enough of the red for the solution to turn yellow instead. All right, so there's some examples for you for either adding common ions or adding something that will react with something that is already in the equilibrium.